Hello, welcome back to another episode of Math with Haas. You're watching Precalculus Season 2, Episode 23. We're continuing our investigation in trigonometry, and in particular we are going to cover some more examples involving arcsine, arccosine, and arctangent. So we're going to begin with discussions such as the following. What do you do when you have arcsine of cosine of pi over 4? Before we tackle that, I want to... Actually, no, we'll just dive in. What the heck. Alright. So, there's a basic order of procedure. So, we have that everything in this box here is inside our arcsine. Well, let's figure out what is that value. So, cosine of pi over 4, well, that's the same thing as root 2 over 2 by reference to our unit circle. If you don't have that memorized, please do so. And so arcsine is this arcsine statement. It's going to be arcsine of root 2 over 2. And so, well, arcsine of root 2 over 2. We want to ask ourselves the question out. Arcsine, or sine of what angle, gives you root 2 over 2. Well, answer to that is pi over 4. And voila, there's our answer. So notice we did this in two steps. Step 1, we evaluated the inside. And then step 2, we just took the arc or inverse trig function, whatever remained after the first operation, and we got our answer. Keep in mind, we have to pay attention to domain restrictions. More on that now. So, suppose we had arcsine of sine of pi over 6. Well, if you recall from before, we have an inverse function inside, or we have a function inside the inverse function, which means by the properties of an inverse function, we should get out whatever x is. So if we have, remember that this property, or that f of f inverse of x is also equal to x, right? You know that this has to equal pi over 6, and sine of, arcsine of, I guess it doesn't matter what we plug in, 1, that is equal to 1. But not so fast. We have to be careful. So these follow straight from our properties inverses, but there's a caveat with the domains and ranges. So let's be the sneaky, tricky math instructor now. So if I were to give you sine of arcsine of 1.2, for example, you might be tempted to say, well, that's equal to 1.2, and wrong. Well, what's wrong with this is the fact that the domain of arcsine is from -1 to 1, and this 1.2 is larger than 1. So since 1.2 is larger than 1, outside domain, so this is actually undefined. Boom, one way you might be tricked. Another way you might be tricked. This is a classic also. So suppose I have arcsine of, sine of 7 pi over 6. Well, you might be tempted to think, that has to be 7 pi over 6 because the sine and the arcsine kill each other off according to these properties right here. But not so fast. That is still wrong. This is one of the weird things. So if we think back to our example here, our first step was to evaluate the cosine pi over 4. So let's do that. Okay, so if we evaluate this sine of 7 pi over 6, sine of 7 pi over 6, that has to equal 1/2. -1/2. Yeah, -1/2. So now the question is, what is arcsine of -1/2? Well, arcsine -1/2 actually has to equal, wait for it, -pi/6. You might be wondering what just happened here. So we have to go back to the unit circle again. So here's our unit circle. Well, 7pi/6, that is this angle way over here. 7pi/6. And yet I claim our answer is actually this one right here. This -pi/6. Both have a y-coordinate of -1/2, so it's plausible. The key is remembering the fact that the range for arcsine of x is actually from -pi/2 to pi/2. And actually that needs to be a square bracket. Alright. So what that is saying is the right side of the unit circle, that is our range here. There we go. There's a nice lovely shade of pink. So even though we have the 7pi/6 inside the sine, and that entire quantity is inside the arcsine, arcsine cannot give you a 7pi/6 because 7pi/6 is outside the range, which means when you take arcsine of -1/2, you actually get our -pi/6. That's another way a math teacher might be tricky. Alright, now let's go ahead and do, I guess, one more fun example. How about arccosine of tangent of pi/4? So this is like before. We consider what is tangent of pi/4. Tangent of pi/4, that's the same thing as sine of pi/4 over cosine of pi/4, which is the same thing as √2/2 over √2/2, which is the same thing as 1. So this is the same question as what is arccosine of 1? Well, the answer to that is actually 0. Or how I like to put it, 0 pi. And it can't be 2 pi because arccosine has a range from 0 to pi. Delicious. So there we are. You can say 0 or 0 pi. I just like having my answers in pi. Doesn't really make sense if everything on the circle has a pi in it, except for when the angle is 0, right? Can't leave no pi left behind, it's 0 pi. Alright, if you've enjoyed this video, subscribe, consider supporting us on Patreon if you enjoy our videos and want to support our project. Thank you for joining our math party, and see you next time.